Welcome to the video lecture. Here we are discussing about the pulse amplitude modulation using Convex optimization. Here are the table of contents, introduction, algorithm, place, problem statement, code, advantages and applications. Pulse amplitude modulation. Pulse amplitude modulation is a type of modulation in which the amplitude of a series of regular pulses is varied according to the amplitude of the modulating signal in the PAM. The modulating signal is used to control the amplitude of the pulses in the carrier waveform. The process of PAM involves taking the analog signal such as voice or music signal and sampling it at regular intervals. The resulting samples are then converted into a series of pulses with each pulse representing the amplitude of the corresponding sample. The amplitude of the pulse is varied based on the amplitude of the input signal. The advantage of PAM is that it is a sample modulating modulation signal modulation technique and is easy to implement. It is used in various communication systems such as digital audio, video, and wireless communication systems. And here is the equation of SNR. You can see of the SNR value in PAM can be calculated with this equation only. And this is the block diagram. And these are the waveforms: message signal, sampling signal, PAM signal. Algorithm we use is convex optimization. Convex optimization algorithm can be broadly classified into two categories: first order methods and second order methods. First order methods compute the gradient of the objective function at the current solution, while second order methods compute the Eigen matrix of the objective function. Second order methods are generally more computationally expensive but can converge faster than first order methods. Next, algorithm. These are the stages. Initialization, define the objective function and constraints. Iteration, evaluate the objective function and evaluate the gradient. Update the solution, check for convergence. Next, at last, termination. Problem statement is that we are going to define the pulse signals as sinusoidal functions with increasing frequencies. Next, we also define the original signal as cosine function. We then define the power constraint as 1.0. We define optimization variable A as a vector of length n, representing the amplitudes of the pulse signals. We define the objective function as the ratio of the average signal power to the average noise power, which we maximize. We also define the constraints which enforce the power constraint of the modulated signal. And here is the code. Advantages of pulse amplitude modulation: simple implementation, low noise, high data rate, versatility, compatibility with digital processing. These are the applications: portfolio optimization, controlled system design, machine learning, and signal processing power systems. These are the applications we use in convex optimization algorithm. Next, we are going to run the code. Here is the code. First, we have to import numpy as np and convex pycharm as cp. Basically, it is a convex pycharm code. We are doing it in Python. Define the PAM signal and define the noise signal and take the noise level as 0.5. Define the optimization variables x is equals to cp into variable. Define the optimization variable. Here we are going to define the optimization variables x is equals to cp into variable and define the function. Next, define the constraints. Next, define the solve the optimization problem, print the solution, print the SNR values. Now we are going to run the code. Hence, the optimal solution is the output is here. SNR is equals to zero point 0.0, and this is the convex optimization of PAM. Thank you.